Hello everyone, I'm Dr. Bell, and I wanted to make this video to explain this project that I brought in that everyone can see and learn from. This will be sort of the beginning of a series of other projects being brought in and other descriptions of the projects. This is sort of a standard project. It takes motors, it takes an Arduino, it takes some physical construction, and the idea here is to create a sign that will be a messaging board that can be changed, different messages as you have different needs. I call it a flip sign, a threefold flip sign, because we have the three panels. Just briefly, what the hardware is: these are three servo motors, and you see that these are standard RC servo motors that go back and forth 180 degrees. And I have a very easy connection, just putting decking screws through these holes into this plastic side here. The two arms here, or the arms pivot, and they're pins that go into pieces of poster board, and then wrapped around the poster board are signs that I make on a printer. The whole thing is controlled by an Arduino that's in this box back here. And the construction, the Arduino is inside. It's a Nano on a special red board that brings out the wires. And then the box itself is made with 4x4 PVC fence post covers. So it's a very simple construction. And then I use a panel from a networking jack as that, with little inserts to hold the wires and make it neat. All right. And then the one last feature here is that it's easy to disconnect these panels by backing off this screw, taking it out of the notch, and then this whole panel comes out. Whoops, careful, watch out for that. The panel comes out, and then this just slides over the end of it. Okay, so let's come around to the computer and look at the software. There you go. Okay, so here's the software, and this is standard Arduino software. I impose upon it, I use a different kind of structure. So you'll see in all my examples a certain structure where I have different areas for comments, libraries, constants, and various other things that we'll be seeing down the software. And in the comments area, I put a brief description of the program or the code. And then we go into the libraries area. You'll recall that it took 3 servo motors, so I have to bring in a servo.h library. It's one of the standard libraries in Arduino. You don't have to go out into the internet and search and find it. It's already there. And just typing this in here, if it turns brown, it means it was able to find it and it knows how to use it. And then there's an area of constants, and these are things that don't change as the program is running. And the new concept that's being introduced here are arrays. These first 3 things here, called steps top, steps mid, and stops bot, are related to the 3 servo motors, and the numbers after the equal sign in the curly brackets are related to various steps in the sequence. The sequence has 10 steps, and they're numbered starting from 0, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, they're 10, I think. Oh, maybe they're 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, but starting with 0, the top one is 9. And we start with 0 because that's how the Arduino likes to number their arrays. So the one on the left, the first one, is a 0. And in this case, it's 9 at the end. And you'll see 0s, 90s, 180s. These are going to be the positions that the servo motor is going to run. The servo motors are going to move to: 90 degrees, 180 degrees, and 0 degrees. And the final array here is wait milliseconds, and this is the amount of time to wait after it sends the command to move. For some commands, you need to have a longer time because the sign is now with the 3 panels up vertical, and so you want to wait longer for the viewer to be able to see it. So we have 4 steps that are 300, and those are moving the panels to get into position. Waits for 2 seconds, or 2,000 milliseconds. Then it does 4 more moves, and then it waits for 2 seconds. So there are 2 sets of panels that are viewed in this software. Now going down, we go to standard code to describe the hardware. So the 3 servos are hooked up to 3 different pins on the Arduino. And this is an interesting part here. You can describe multiple objects, or multiple servos in this case, and give each one a name. So on lines 21 to 23, I've given them the names of servo top, mid, and bottom. And by convention, you like to have when you have names, the leftmost part is the name that doesn't change, and the rightmost part is the name that changes the most. So it's Stervo is applied to everything, and then the rightmost part has the different things, or the different servos. And that's because it's a lot easier to edit things if you start editing from the right side and not from the left. So you try to keep the variable stuff on the right side. And now, going into the setup, you all know about the setup and the loop functions. So we start out by setting up the hardware, and it's a simple attach, and then you tell it which pin on the Arduino to attach to. And remember, they were 8, 9, and 10 up there. And then I, as a convention, always hook up the serial port and send out a message that describes what the software is, so that I can come back later and find out what software is on the Arduino, and then something about how the Arduino is connected up to the hardware. So it's going to send out the message about which lines are being used to connect up. Now that's the setup. Setup's finished. One runs once, and then we get into the loop that runs all the time. Now you've learned about for loops, and you see I used 2 of them. One goes through the step numbers. Remember I said up at the top when I was talking about arrays, they went from 0 to 9. We're using those 2 numbers to say go to step 0, 1, 2, 3, and then up to 9. So this middle thing says do it while it's less than or equal to 9. So this loop, outer loop, stops when it gets to 9. And now within each loop, it needs to move the servo motor from one position to the next. And this is probably the trickiest concept in the whole thing. So I'm just going to describe the one aspect here, and this is called map here. If you go to the reference by clicking on with the right click, whoops, no, I'm sorry. If you are highlighted in one of the words and you go up to help, and you do find in reference, it will take you out to the internet and will show you what the values are that it expects in this area here. But I'll tell you now that map takes one number, in this case move number, and it finds out where it is in a range. And we know since move number is going from 0 to 90, it's always going to be between 0 and 90. And wherever it is in that range, it takes the next 2 numbers and applies it the same proportion to the range of these 2. And essentially these 2 numbers here between the comma are a value that is the sequence, and then the next value. When you see step num plus 1, that's saying take the next one in the sequence. Now, of course, this is going to run in a loop, so it goes all the way around. And I use a thing called modulo. It looks like a percentage sign, and on your keyboard it's a percentage sign. And if you do a modulo 10, it's dividing that number by 10 and then just using the remainder. So the number never goes up above 10, it loops back to 0. And the reason we do that is that when we're at the 9th step, it needs to look ahead and look to the next step, which is actually 0. So by doing it this way with this modulo 10, it's going to look for the 0th, or the first one in our list, value there. And so if we just briefly go back up here, when we get up, we go 0, 90, 90, 80, 180, up to here 0. The next one is going to be read as this 0 here. And that starts the loop over again, and it makes it consistent. But what's happening here is that it's writing a position to the servo motor, and in these 3 lines it's writing 3 positions to the 3 servo motors. So they're not all in the same position at any time. And then it goes to the next and the next in steps of 0 to 90, so that it goes at a certain speed, and they're all moving at the same speed. The 90 is not important. It could have been 100, it could have been 180, it could have been probably a number greater than 90 to use it to make smooth steps. But it's not important that it's the 90 there. All right, now we're almost done, because after we make that move, we do a delay, and that was a move seconds. And remember that the motor has to take a certain amount of time to go from one place to the other. That's why we introduced this delay. And then down here, we wait a bit, we print what the step number is, and then we wait. This was that other array, remember it said 300, 300, 300, and then 2000. That's what's happening here. So as step number goes from 0 to 9, it's pulling down what those numbers are. So first time it'll wait 300 milliseconds, and the 5th time it'll be 2000, and then the last time it'll be 2000. So that's it for the software. I'm just now, before I hook the the sign back up again, I'm just going to show you the serial monitor. So this is running the serial monitor, and then it's not running the actual servo motors. I don't have them plugged in. But you see here, I have a message that tells me what the software is, so I can find the software again through a search. And it tells me where to connect up the digital lines, 8, 9, 10. And I didn't point it out, but it also tells where I am in the sequence. So you see we're going 0 to 9, 0 to 9, 0 to 9. So this is the function that's looping it back. So now let's turn this off, and I'm going to plug in now the sign again, and we're done at looking at the screen. So let's go back now and look at the motors turning and look at the sequence briefly here. So I'm going to plug it in. The Arduino is starting up right now. It's going into the setup loop and creating those objects. And now it's starting to turn. If we were looking at the computer screen, we'd see those messages that I just pointed out. But just focusing on the top servo motor, see how it goes from a 0 to 90 to 80, and then it waits for 2 seconds, 0 to 90 to 80. If we were to go back to the sequence, we would see that. And in this case, it goes 0 for a while, hangs out, then 90 to 180, and then it'll go back to 90, 180, but not at the same time as the one at the top. And the third one has a totally different sequence as well. And so by doing this, we go from one set of surfaces to the other set of surfaces.